Hello everyone and welcome back. So let's see how we're going to implement this with Arnold. And these techniques should be applicable to all the render engines. Now the first thing is we don't need this high-res geometry. I'm going to go back here. I'm going to turn off the divide, and this is what we will use. Okay, now I don't need the displacement to happen here. And this is all I need. I have the X and Y vector, and we have a rest attribute. Okay, so let's create a camera and zoom in to this object. I'm going to copy this name and go to the out context, create an Arnold node. And force object, I'm going to make sure that I'm using that one. And then go to the render view and hit render. Okay. So it doesn't have a shader. I'm going to go to the shop context, create an Arnold shader, call this render time disp or edge disp, and let's dive inside. I'm going to create a standard surface, and I don't need a standard surface at the moment. I need something else. So I'm going to use a wireframe. Yeah, I'm going to use a wireframe, and this will allow me to see the triangles on the mesh. Let's change it to polygons and make sure that this is assigned to the geometry. So we go to the render tab, material, and assign this, and that's our geometry. Now what we need is we need to subdivide this. So if we go to the render Arnold tab, and under subdivision, I'm going to change it to, I'm not going to change it to cut mode because you guys know that it's not going to work. It needs to be linear. If we use cut mode, it's going to smooth the geometry and its boundaries. We don't want that. We want to use linear, and you can see already it's triangulated and it's subdivided the mesh. So I'm going to change this to 2, and that's not enough. I'm going to change it to 3, 4. Cool. So we have 4, let's go 5. That's too much. Let's go 4. Cool. So we're going to use 4 subdivisions, and now we need to reapply the same thing that we did. So let's go back to the render, and let's create a noise pattern. And this is what I was talking about when it comes to noise. Right now, this is only in Arnold at render time. We don't have the same node in SOP, so we cannot visualize it. And I'm going to connect this node to the surface, hit render, and that's our noise. Let's increase the scale. This version has a bug. I need to hit render every time to get the update. And let's lower, and let's increase the octaves. Okay, let's increase this. Cool. So we have some details, and we have to make sure that it's using the coordinate. It's using the pref attribute, and it's by default it's looking at the rest. And this is going to make sure that the noise sticks to the mesh as it transforms. Okay, so we have the other vectors that we need to import. I'm going to use a user data RGB. RGB can be used for vector. We're going to import the X. I'm going to call it X vector. Y vector. It's Y and Y vector. And we're going to multiply, like we did, these two with the normals, with the noise. So multiply. And I'm going to multiply this as well. I'm going to multiply the vector first with the float. And here I'm going to use the red channel only to make sure that I get a float. Okay, so that's my result. And I'm going to combine both of them. And I'm going to, after we add them together, we're going to plug this into the displacement attribute. And I'm gonna set this, I changed it offline. So I'm going to hit render, and this is the result that we get by plugging in the result of these two vectors into the displacement and with a value of 1. So we need to lower this. Let's set it to 0.1 and hit render, and this is the result that we have. But if we look closer, we see something is happening to the mesh, but it's not what we're looking for. And the reason for that is that because our displacement cannot happen in this space, this is happening in world space. We need to do the displacement in local space or object space. And to do that, we're going to use a transform node, a space transform node, sorry. A space transform node. We're going to transform it from world space into object space. And if we hit render, now it's going to work properly. See? And let's lower the noise a bit more, 0 to 5. And hit render. Let's increase it 5. And if we use a jitter node, color jitter, and let's connect this here and hit render. I'm gonna say per object. Hopefully this is going to work. And I'm gonna create a flat color, or let's plug in this wireframe, and I'm gonna change this color to, let's say, orange, so I have something to work with when I shift the hue. I'm gonna use a color jitter, and I'm gonna randomize shift the hue here, and let's hit render. Per object didn't work. Yeah, we need an ID. Let's try this. Yeah, we need an ID number to be able to color the pieces. Okay, which we don't have, so that's fine. We'll use this for now, and we'll plug in. We'll create the ID. We'll create the ID later. Now, the last bit, I came back to SOP, sorry. So the last thing we want is we don't want to affect the boundaries like we did. So we're going to provide that mask attribute, and I'm gonna go back here and delete this node, and I'm gonna pass the red mask after we did the transfer as an attribute. So I'm gonna create a Wrangle node and say f@mask is equal v.cd.x, and that's a float, and then we will pass the data to the render. So let's go to the out context and hit render, and if we go to the shop and import that attribute, and it's going to be a float, user data flow, a scalar, sorry, come on, user data float. Okay, so I'm going to import the mask, and let's hit render. This is our mask and how it looks like. Sometimes, because our initial geometry is very low res, sometimes you'd have to have a couple more points. You'd have to subdivide the mesh at least one time so that this mask works and has enough details. But right now it's being interpolated across a huge surface. So and it's white on the edges, so we need to invert it. I'm going to use a complement node, which is 1 minus the color. And if we hit render again, you see everything outside is black, and that's what we're going to use as a multiplier. Now this node, the transform, has a scale. I'm going to simply plug this in, and let's connect our wireframe and hit render. And boom, we have edge displacement inside and nothing on the outside. So if we go to a different frame, say this, or maybe as it starts to separate, something like this. Yeah, and do a render. You can see we have a lot more details, and I'm gonna create a couple of lights so we see it better. An Arnold light, it's going to be a sky dome with a bluish color tint, and I don't want it to be visible. And let's go back to the shader and put down a standard surface and hit render. Cool. So that's our surface displaced and working. Now the other thing is we are also affecting the inside of the faces, but we don't have to. Okay, we can create another mask, and I will show how. We can create another mask that finds the edges and only apply displacement to the edges. But right now we're applying it across the board, which is fine, but we can mask it and get rid of these issues. And you can see that the render is quite fast now, and we're getting interior details and all that stuff, which we can mask if we wanted to, but in this case, in my scene, I didn't have to. So let's go to a different frame. Okay, so let's go back here, and I want to do a test with and without. So this is it. I'm gonna stamp this image, and I'm gonna disable the displacement, hit render again, and this is our current result. This versus this, this versus this. Cool. So the next video we're going to tackle the UV issue, and we'll implement that in the next video. Thank you guys for watching, and see you in a bit.